Hello, welcome, and we are going to talk about alpha carbon chemistry. Now, before we start, I would want to reiterate that this video is not a replacement for the lecture notes. So you need to read the lecture notes carefully, follow the links provided over there, study and practice. If you do have any questions, let me know. So the alpha carbon is the carbon that is adjacent to the carbonyl. So the one that comes after that, we call it beta carbon. So our focus is going to be on deprotonating the alpha protons to generate enols and enolates. For example, we can start from a ketone and use a strong base to do deprotonation in order to form an enolate. The enolate is resonance stabilized. In the presence of bromine or any electrophile, the enolate is able to undergo a nucleophilic addition. And then in this case it installs bromine in the alpha position of the carbonyl. In other cases, we can have a ketone undergo tautomerism in the presence of catalytic amount of an acid or a base to form an enol. The enol, in the presence of an electrophile, can undergo nucleophilic addition to install an electrophile in the alpha position. So there are two key things here. One is we need to be able to identify the pKa of the alpha proton. Second, we need to identify an appropriate base that would be able to deprotonate the protons in the alpha position. So for example, if we look at the diketone here, or we can look at the acetoacetate or the diester here, their pKa's range from 9 to 13, which means we can use sodium hydroxide or we can use sodium ethanoate, that is any alkoxide, to be able to fully deprotonate these compounds. Now, if you want to deprotonate a ketone, an alcohol, or an aldehyde, we would need a base whose conjugate acid has a higher pKa than the compound we want to deprotonate. So if we try to use something like sodium ethanoate or sodium hydroxide to deprotonate a ketone, then the ketone will not be fully deprotonated, so it's going to exist in equilibrium with the enolate, and then the enolate will be able to attack the ketone to form what we call an aldol product. If we want to fully deprotonate a ketone, we must use a base whose conjugate acid has a higher pKa than the ketone. So something like LDA or sodium hydride. LDA is formed from diisopropylamine. So we call it lithium diisopropyl amide. That is the amine which has lost a proton. So we can use the LDA, or we can use sodium hydride to be able to deprotonate some of the compounds that have higher pKa's.